Right now, as you are watching this video, your engine is building pressure. Not slowly, not gently. It is building pressure the same way a boiling pot of water builds pressure under a sealed lid. And somewhere inside your engine block, a tiny plastic valve that costs $8 is either doing its job or slowly failing. And you have absolutely no idea which one it is. If it is failing, and statistically there is a very good chance it already is, you are not just looking at a minor repair. You are looking at the moment your mechanic hands you an invoice for $2,000, maybe $3,000, looks you in the eye with a completely straight face, and tells you that your rear main seal has blown. And here is the part that will make your stomach turn. While your car was up on that lift, while you were sitting in that waiting room drinking bad coffee and scrolling your phone, that mechanic reached under your hood, found an $8 plastic part, pulled it out, dropped it in the trash, clicked in a brand new one that took him approximately 30 seconds, and then billed you for a catastrophic engine failure he never told you about preventing in the first place. I want you to understand something before we go any further. The information in this video is genuinely dangerous to the automotive service industry. Not slightly inconvenient, genuinely dangerous. Because what I am about to walk you through is a maintenance task so simple, so cheap, and so devastatingly effective at preventing some of the most expensive engine repairs on the market that its removal from standard maintenance schedules was not an accident, not an oversight, and not a technical decision. It was a financial decision, and the people who made that decision have been collecting on it for the better part of 2 decades while your engine quietly suffered the consequences. To understand what is happening inside your engine right now, I need to take you somewhere most drivers never think about. Not the top of the engine where you pour in your oil, not the exhaust system where the burned gases escape. I need to take you to the crankcase, which is the very bottom of your engine block, the sealed chamber where your crankshaft spins and where your engine oil lives. This is one of the most mechanically violent environments in the entire vehicle. Your pistons are firing hundreds of times per minute, and every single time a piston fires, a small amount of combustion gas slips past the piston rings and gets forced down into the crankcase. Engineers call this blow-by. It is not a defect, it is not a sign of a failing engine. It is a completely normal, unavoidable byproduct of internal combustion physics, and it has been happening in every gasoline engine ever built since the dawn of the automobile. Now here is where the analogy comes in, because this is the part that makes everything click. I want you to imagine your crankcase as a pressure cooker sitting on your stove. The burner is on, the water is boiling, steam is building up inside. And every modern pressure cooker has a small relief valve on the lid, a little weighted piece of metal or plastic that lifts when the pressure gets too high, releases the excess steam safely, and then seats back down again. Your engine works in exactly the same way. The Positive Crankcase Ventilation system, which engineers universally abbreviate as PCV, was designed as that exact relief valve. The blow-by gases that accumulate in the crankcase get routed through a rubber hose to this small valve, typically a simple cylindrical plastic or metal housing about the size of your thumb, and from there the gases are safely drawn back into the intake manifold and burned off through normal combustion. The crankcase stays at a safe, stable, slightly negative pressure. The engine breathes. Everything works perfectly. The genius of the original PCV system is that it is almost insultingly simple. There is a spring inside the valve, there is a small plunger. At idle, when intake vacuum is high, the spring keeps the plunger mostly closed to prevent too much airflow from leaning out the mixture. Under load, when vacuum drops, the plunger opens and allows the crankcase to vent more aggressively. It self-regulates. It requires no electricity, no sensors, no computer control. The original engineers who developed this system in the 1960s, when it became federally mandated as an emissions control device, built something so mechanically elegant that it genuinely should last the life of the vehicle if maintained correctly. And maintaining it correctly means one thing: you replace the valve on a schedule, because over time the oil mist that passes through it deposits carbon and varnish on the internal spring and plunger, slowly restricting and then completely blocking the valve until it can no longer move at all. When that valve stops moving, your engine is now a pressure cooker with the relief valve glued completely shut. The blow-by gases have nowhere to go. Crankcase pressure begins to build, and it builds relentlessly because the pistons are still firing, still pushing combustion gases past the rings, still adding to the pressure with every single engine revolution. Your engine is now running at a slight positive pressure inside the crankcase, instead of the intended slight negative pressure. And that difference, that seemingly small shift in pressure direction, is catastrophic in slow motion. Because your engine has seals, gaskets, points where two machined surfaces meet and are held together by compressed rubber or cork or composite material designed to contain oil under normal operating conditions. Those seals were never designed to resist positive internal pressure. They were designed to keep oil in, not to resist pressure pushing oil out. So the crankcase pressure begins looking for the path of least resistance, the way water finds every crack in a basement wall, and it finds two places almost every single time: the rear main seal, which is the circular seal at the very back of the engine where the crankshaft exits the block to connect to the transmission, and the valve cover gaskets, which sit at the very top of the engine and seal the valve train from the outside world. The rear main seal is particularly vulnerable because the crankshaft is spinning at high speed against it constantly, and the moment positive pressure starts pushing against it from inside the crankcase, the oil begins seeping past. At first, it is just a trace, a slight oil film on the bottom of the bell housing, then a drip, then a steady weep that leaves a dark stain on your driveway, and by the time you notice it, by the time it's bad enough to bring the car in, the seal has already been compromised enough that the repair requires dropping the transmission to access it. Let me give you the exact historical moment when the industry decided you should not know about any of this. For decades, PCV valve replacement appeared on standard maintenance schedules. You would find it in your owner's manual. You would find it on the laminated service interval chart hanging in quick lube bays. Typically, it appeared at 30,000 miles, or sometimes every 2 years, whichever came first. It was listed alongside air filter replacement and spark plugs as a routine consumable maintenance item. This persisted through the 1980s and into the 1990s without controversy, because it was simply correct engineering practice. Then, something changed in the mid-2000s. Automakers began rolling out what they marketed as extended service intervals. The pitch to consumers was attractive on the surface. Better oil chemistry and improved engineering meant less frequent maintenance. 30,000-mile oil changes were pushed to 5,000 or even 7,500 with synthetic oil. Tire rotations were stretched, and quietly, without fanfare, no press release or engineering justification, PCV valve replacement disappeared from the recommended service schedules of virtually every major automaker selling vehicles in North America. Not reduced in frequency, removed entirely. The valve was reclassified in many internal service documents as an inspect-only item, which in practice meant no one ever actually inspected it, because there is no simple visual inspection that reveals a clogged PCV valve without removing and testing it. The interval was effectively set to never. What happened to rear main seal replacement revenue in the years following that decision is not a coincidence. The automotive repair industry saw a sustained, significant increase in oil leak repair tickets, particularly those involving rear main seals and valve cover gaskets, repairs that almost universally require significant labor, often between 5 and 15 hours of shop time depending on the vehicle, and that command prices between $1,500 and $4,000 at dealerships and independent shops alike. The valve cover gasket on many modern engines requires removing the intake manifold, unplugging dozens of sensors, and accessing components that are designed to be repaired by professionals with specialized tools, not changed in a driveway in 30 seconds. But the PCV valve that caused the failure in the first place takes 30 seconds to test and under 5 minutes to replace. The profit math here is so brutally obvious that it barely needs explaining. They didn't build the PCV system to last forever. They built the service model around the moment it failed. Now, let me give you the proof, because I'm not asking you to take any of this on faith. Commercial fleet operators, companies running hundreds or thousands of vehicles simultaneously and tracking every maintenance dollar with precision, discovered this relationship through hard data long before it became widely discussed. Long-haul trucking companies that maintained strict PCV system inspection protocols on their diesel engines consistently reported dramatically lower rates of crankcase seal failures compared to industry averages. In documented internal fleet analyses by major logistics companies,